compact biogas plant. Many rural households use biogas as cooking fuel. The traditional domestic biogas plants require a daily input of 40 kilograms of dung mixed with about 40 liters of water. It takes about 40 days for the dung to start producing biogas. In order to accommodate the daily input of 40 kilogram dung and retaining it in the plant for 40 days requires a plant having a very large capacity of about 4 cubic meters. Because of the large size, such a plant requires a lot of space and its cost is also high. Because of dwindling population of cattle, the availability of dung has declined, causing many of the existing biogas plants to stop functioning. Appropriate Rural Technology Institute, ARTI, has developed a new compact biogas system which is very easy to use. This biogas plant works on starchy, sugary, cellulosic or fatty substances. Thus, one can use oil cake of non-edible oil seeds like pongamia, neem, castor or shoria, damaged or overripe fruits, rain-damaged grain, flour swept from the floor of a flour mill, fruits of ficus, insect-damaged grain, non-edible rhizomes of banana or canna, tea leaves, or any other similar substance as feedstock. Leftover and stale food can also be used as feedstock. The feedstock must, however, be pulped or ground and applied to the biogas plant after mixing it with about 5 to 10 liters of water. About 1 to 1.5 kilograms of starchy material would yield sufficient gas to cook the meals of about 4 to 5 persons. The amount of gas generated every day depends upon the capacity of the fermenter and the gas holder. Fermenter capacity 500 liters. Gas holder capacity 400 liters. Available gas 250 liters. Duration of burning 1 hour. Fermenter capacity 1000 liters. Gas holder capacity 750 liters. Available gas 700 liters and duration of burning 2 hours. Fermenter capacity 2500 liters. Gas holder capacity 2000 liters. Available gas 1750 liters and duration of burning 5 hours. There are various ways in which this biogas plant can be fabricated. This plant has been fabricated with the help of 2 plastic tanks. This one has a cement concrete tank as the fermenter and a plastic tank as the gas holder. This third model has its fermenter tank made of sheet metal, although the fermenter tank is made of different materials. The gas holder tank is always made of plastic. Let us see how to fabricate a biogas plant having a fermenter of 1000 liters and a gas holder of 750 liter capacity. The material required for manufacturing this plant is black colored molded plastic tanks one having 1000 liter capacity and the other of 750 liters. 90 mm T, 1 piece. 90 mm female adapter, 1 piece. 90 mm male adapter, 2 pieces. 90 mm end cap, threaded, 1 piece. Rigid PVC pipe having 90 mm diameter, 2 meter long, 1 piece. Elbow of 63 mm, 1 piece. 63 mm male adapter, 2 pieces. 63 mm check nut, 1 piece. 63 mm rigid PVC pipe, 90 cm long, 1 piece. 12.5 mm PVC male adapter, 1 piece. 12.5 mm galvanized iron elbow, 1 piece. Epoxy resin and hardener. PVC adhesive solution. Biogas stove, 1 piece. Gas cock, brass, 1 piece. Ball valve, 50 mm diameter, 1 piece. The fabricator would also require a set of hand tools. They are file, hammer, sickle, large hacksaw blade, 2 pieces. 90 mm barrel piece, 63 mm barrel piece, 50 mm barrel piece, 12.5 mm barrel piece. First, take the 1000 liter tank. Cut its top in this manner. Perforate it near the base by pressing preheated 90 mm barrel piece against it. Then perforate the tank also near the bottom, but with a 50 mm barrel piece. Make a third hole at this position with the help of the 63 mm barrel piece. The tank has now 3 holes, 1 near the top and 2 near the bottom. Now apply PVC adhesive to the 90 mm male adapter and fix it into this hole from inside. The threads now protrude out of the tank. Fix a female adapter on it like this. Wipe the inner surface of the adapter with a piece of cloth and apply PVC adhesive to the inner surface. Apply PVC adhesive to this piece of 90 mm pipe on the outside surface and fix it into the female adapter. Now take the 90 mm T and apply PVC adhesive to it on the inner surface and fix it on this end of the 90 mm pipe like this. All these pieces together should form a continuous linear horizontal pipe. Apply PVC adhesive to the internal surface of the free end of the T like this and fix this piece of PVC pipe into it. Fix a male adapter on this pipe like this. With the threaded end projecting outwards. Fix an end cap on the threaded end. Fit a 120 cm piece of the 90 cm PVC pipe vertically into the T-piece like this. This represents the inlet for the feedstock. Fit a funnel on the top end of the inlet pipe. Fix a 60 cm piece of the 90 cm pipe to the adapter on the inside of the tank. The free end of this pipe should project into the tank up to its center. Now, fit the 63 mm adapter into the hole near the top of the tank in such a way that the threaded part projects into the tank. Screw a check nut on the adapter like this. Fix this 45 cm long piece of the 63 mm pipe into the adapter with the help of PVC adhesive. This pipe projects horizontally out of the tank to serve as the outlet pipe for the spent slurry. Now look at the third hole. Fit an adapter into this hole so that the threaded portion projects out of the tank. The threads should be covered with Teflon tape. Screw this ball valve on the adapter and fit it tightly. Mix epoxy resin and hardener and apply this mixture to all the joints wherever a pipe is fitted to the tank. Place bricks inside the fermenter tank to create a support for the gas holder cap to rest on. The gas holder is fabricated from a tank having a capacity of 750 liters. The upper part of the tank should be cut like this. Then, invert the tank and using the 12.5 mm barrel piece, cut a corresponding hole into its base like this. Fit the 12.5 cm male adapter into this hole in such a way that the threaded part projects outwards. Fit the galvanized iron elbow on the threads of the adapter and screw in the gas cock like this. The joint between the elbow and the tank should be sealed with epoxy adhesive like this. We have now the gas holder ready. We have so far seen how to fabricate a gas plant with an external feed pipe. The feed pipe can also be fitted inside the gas holder tank. For this purpose, the mouth of the smaller tank is cut in this manner. The cut edges are to be filed smooth. This tank is to be perforated at this place. The hole should be marked by placing an adapter at this place. And the perforation is made in this manner. Fit a PVC male adapter in this hole and secure it with the help of a check nut. Now, lay the tanks on its side and cut a hole exactly opposite the existing one and fit a female adapter into it like this. Seal the joint with an epoxy adhesive. Now, cut a length of PVC pipe exactly equal to the distance between the two holes and fit the pipe between the two adapters. This pipe would serve as the inlet pipe. There is no need to fit an inlet pipe to the fermenter vessel. We now have the inlet pipe fitted into the gas holder. The biogas plant can be installed at any convenient place, but this place should receive direct sunlight. Clean and level the ground and place this large fermenter vessel on it. Mix about 40 to 50 kilograms of dung and mix it with about the same quantity of water. All the extraneous matter in the dung should be removed. Break the lumps of the dung and make a nicely blended slurry and fill the same into the fermenter tank. One should also add to the fermenter a couple of buckets full of slurry from an existing biogas plant. Fill the tank with water. Then place the gas holder tank into the larger fermenter tank after opening this gas cock. After the gas holder has sunk halfway into the gas holder tank, close the gas cock. If the gas holder sinks into the fermenter even after shutting off the gas cock, it is an indication of the joints leaking air. The joints should be tested with the help of soap water. A leaky joint would produce soap bubbles like this. If the gas holder remains floating on the fermenter at the same level for more than 10 to 12 hours, it means that all the joints are airtight. In that case, one should open the gas cock again and allow the gas holder to sink completely into the fermenter vessel. Once the system starts producing biogas, the accumulated biogas lifts the gas holder out of the fermenter. After the gas holder starts rising, open the gas cock and hold a lighted candle near it. If the gas burns, one can connect the biogas plant to the gas stove. The gas holder often tilts to one side, but this can be prevented by providing it with appropriate supports in the form of bamboo poles, iron rods, or a guard fabricated by using pipes. The fermenter tank can be made from galvanized iron sheet of 24 to 26 gauge thickness. One can also fabricate the fermenter with the help of bricks and cement. For good performance for your biogas tanks, you should abide by the following instructions. The feedstock must be finely ground or pulped. If the feedstock is not powdered or pulped, It may cause choking of the feed pipe. Start adding feedstock only after the gas plant has started to produce combustible gas. This gas should burn with a clean blue flame. Initially, introduce only 300 to 400 grams of feedstock into the biogas plant. Increase the feedstock quantity gradually. The stretch of the gas pipe between the gas plant and the stove should be straight. If there is any slack in it, water would accumulate in the slack portion of the pipe and block the movement of the gas. If the gas pipe gets choked due to water, disconnect the gas pipe and remove the water like this. If it becomes necessary to drain the tank for cleaning, first open the gas cock and then open the ball valve provided at the base of the fermenter. The gas cock should be opened very gently and the slurry within the fermenter should be let off in a small trickle. Do not open the ball valve fully. The rate of biogas generation depends upon the weather. The gas formation is faster in summer. So the newly started biogas plant would start producing biogas within just 3 to 4 days. Whereas during winter, it may take up to 15 days to start producing biogas. Causes of stoppage of biogas. Overfeeding. The number of methanogenic bacteria in the biogas plant is determined by the size of the digester. Therefore, the quantity of feedstock to be applied daily is also limited by the digester size. Feeding more feedstock than the rated quantity causes breakdown of the system. The bacteria also need water for digesting the feedstock. They cannot work properly without receiving their daily recommended quantity of water. The biogas plant would not produce biogas without the daily input of feedstock and water. The biogas plant fails to start if the dung or the slurry used as the starter is less than the recommended quantity. If the digester is not completely filled with water, the biogas plant produces less biogas than its rated capacity. Measures for restarting a non-functioning biogas plant. Reduced biogas production means reduced rate of digestion of the feedstock. In such cases, reduce the feedstock quantity to match the gas production. Otherwise, the non-utilized feedstock would go on accumulating in the digester and the system would eventually stop functioning. Test the pH of the medium in the digester by using pH paper like this. Ideally, the pH should be 7. If the pH is less than 7, mix 1 kilogram lime, that is calcium hydroxide, with a bucket full of water and pour the mixture into the digester. Biogas production should start in about a week. Test the pH again and repeat the procedure till the value of pH 7 is achieved. Do not put any feedstock into the digester as long as the biogas plant is not generating any biogas. Keep the gas cock of the gas holder closed when the biogas is not being used. If leakage of biogas is suspected, test all the joints by applying soap water to them. Leaky joints and other leaky spots should be sealed by applying to them a mixture of epoxy cement and hardener. If the quantity of biogas gets reduced due to cold weather, reduce the quantity of feedstock proportionately. The quantity of gas depends on the type of feedstock. Dung, paper, or material like leaves and stalks of green vegetables yield less biogas than sugar, starch, protein, fats, or oils. If the gas holder tank is full of gas and yet the gas is not delivered to the stove, check the rubber pipe carrying the biogas from the gas holder to the stove. Remove any twists or folds in the pipe. Gas flow can also be blocked by accumulation of water in the pipe. In that case, disconnect the pipe from the gas holder and the gas stove and tilt it to remove the accumulated water. Also check if the pipe is not blocked by dirt or any other obstruction. Remove the obstruction. We provide training in biogas plant fabrication and installation in our institute. And we also provide the biogas entrepreneurs with clients. For developing this compact biogas system, our institute received Ashden Award for Sustainable Energy for the year 2006 in a ceremony that took place in London in June 2006.